Today we're going to be talking about writing the data access code and also the integration test. If you haven't done so already, make sure you check out the last video where we talk about choosing your database technology, designing the schema, the different ORM choices between Dapper and Entity Framework, setting up our local environment, and actually scaffolding out the schema. Before we begin writing any data access code, I actually just want to go ahead and clean up some of the existing code that was from the template. So that's the weather forecast. So I'm just going to delete this. We're going to delete this as well. And delete the class one. Make sure we can rebuild and clean up any references left over. So the first thing we're going to be doing today is creating our entities and make sure that they mapped to the ones that we created for the tables. So all of the properties will match. And then we will be creating our repositories along with an integration test for each action that we want to do to make sure that the repositories work as we expect it to. Since we already have the recipe entity, let's open that up and see what we will need to add. And let's also open up the recipes table. Now the advantage is we will have the schema definition next to the object representation, and we can actually just match it one-to-one. So we know that this is going to be a GUID, and it's going to be ID. We have the title already. We'll need to add description. We'll also need to add the logo. And we will also need to add a datetime offset for created date. So let's leave that as is for now. We'll need to come back and add a little bit more detail to this after we add our instruction and ingredients. So let's do that as well. Let's open up ingredients and drag it over to the side here. Copy the name and let's add our ingredients. Entity, make that public. Now we can take a look at what we have. So we have a recipe ID, so that's going to be a GUID. And we have a ordinal position unit. So string unit. Let's add a float for quantity. And ingredient itself. Save that. Next, let's add the instructions. Drag that over there. Normally, I would also have a little bit more screen real estate, but because I'm so zoomed in, makes it a little bit more difficult. Entity, instruction, same idea, copy the same ones. And for sake of time, I'm going to go here and we can just go over, copy all of this, paste it here, delete, and copy that. And we're done over here. Now that we have all the entities set up, we need to go back to our recipe entity because we want to actually have a reference to the different one-to-many relationships in our recipe. We can actually add at the bottom here, iList, so that we can have access to the add functionality, ingredient entity. And we want to say that this is, I will close this so you guys can better see, ingredients, because recipes will have a list of ingredients. Same idea. We will have our instructions. And we will call that instructions. And just for the sake of this tutorial, because we want to avoid any null reference errors, we want to set a default value of new And same idea for the instructions. Okay, and our entities will match the database schema perfectly. So we have a one-to-many relationship with the instruction ingredients with the recipe. We have that represented here. All of the properties match up. The types are correct. And we can get started writing our repositories. So to start, let's talk about why we want to have repositories in the first place. By having all of our data access code in one area, we can have a nice isolated and predictable place to actually have them. So if we were to share our repository across to the controller, to the domain service, all of those different services will use the same repositories. And if we were to modify, let's say the recipe, update the existing columns, add new columns, we will just need to change the recipe entity and the repository, and all of the data access code will be updated. By having the isolation, it will actually allow us to write tests for each one of these individual methods that we will produce. This is super useful when you're making a bunch of different changes to verify that the change you make actually will work correctly. Getting started inside of the repository, we're going to be creating our insert functionality. So we know that the application as a whole is going to be CRUD-based. So we need a create, read, update, and delete. But let's focus primarily on the insert first. We'll create a test for that, and then we'll go back and add all the other functionality afterwards. So let's delete this method. I'm going to create a interface. So public base, and then we're going to be inheriting that into this. And now let's define our insert command. So we're going to say it's a task because it's going to be asynchronous. And that's going to return back a integer, which is going to be the rows changed. We're going to say insert async, and then there's going to be recipe entity, and we're going to expect an entity to be passed in. Now let's implement the interface. Now we got the empty interface here. So we're going to be adding two packages now. We're going to be adding Dapper, and then we're going to be adding a system.data library we'll need as well. First, let's add the system.data library. So you can actually get Visual Studio to auto trigger that, or you can just go to the NuGet package and install it there. So I'm going to use Visual Studio to actually auto generate it. So var connection, we're going to open a new connection, new SQL connection. And this will be expecting us to install system.data.sql client. So we can say install with package manager, and it should pop that open. And obviously it's not going to be installed. So we'll go to browse, install this version here, 4.8.2. The version, just have to make sure it's compatible with Dapper. That's good. And then now let's also just look for Dapper since we have this open. Install that. I'm on 2.0.78. Okay, go back here now. And then we should be able to resolve this namespace. Okay, perfect. And for the sake of just setting up the insert really quickly, let's put the connection string here first. And then we'll move this to the app settings afterwards, but for now we'll add it here. And the connection string is just the server name, the port, which we configured in our Docker Compose, name of the actual database, the user, the password that we've specified, and that's about it. So we should be able to connect to the database. So now all we have to do is actually just write our query. So let's say we type connection dot execute async. So this is a command with Dapper. So you can say see using Dapper. And this will perform an insert for us. So we'll go like this, type @ to allow multi-line editing. And what I'm going to do is I'm going to switch over to SQL. And generally when I write SQL queries, I script it out like this. And then I take query, kind of clean it up a little bit here. So I remove all of these little variables. That. And then I do one of these multi-line edits, change that to an @ and now this is ready to be used inside of the insert. So we'll go here. Now I'm going to paste it like this. And let's just move that back over here. So what this query will do is we're going to be expecting the recipe entity, and we're going to map each one of these properties to these variables. So @ID, @title is a key value here that will map when we pass in the parameters. So next thing we do is pass in the parameters. So we can type comma, and then you can see from the overload, the SQL query itself, then the parameter is what we're going to be entering. So we can say new, and since it's an object, we can just go like this and pass in the objects like this. So next is to just map the objects. So we say entity dot ID, and then we go entity dot title, entity dot description, entity dot logo, and entity dot created date. So there's another way you can write this, which is just by doing it like this. But you'll get a suggestion from Visual Studio that it's simplified down to just using the inferred name. Because if this matches this name, then it's no big deal. But if these names actually do not match, then you're going to have to explicitly match them. So for example, I can just say logo ASD like this, and then I would then have to specify that that is the parameter name, and then they would map correctly. But since they're one-to-one at this point, it's simple enough to just be able to type it like this. Should have everything we need. So let's put a semicolon here. I'm going to bring this down just so we can have a little bit more space to see. And then I'm just going to format this a bit over. So what I'm going to do is I'm going to take this, I'm going to line it up here. Same idea with this, line it up over here. We wanted to get the rows affected, right? So this execute actually returns number of rows affected. So we can say var rows affected equals, and then we want to await this because this is asynchronous. And we'll take this and return that back to the top, but we want to make sure we put an async up here. So this should now work. And also using Dapper strictly, it will actually open a connection. So typically you would have to go connection.open like this. But because Dapper has that built in, if you don't actually open a connection, it'll open a connection when you run the execute command. Let's go ahead and write a simple test to actually verify that this functionality works correctly. So I'm going to just minimize some of these down, give ourselves a little bit more space. Close this, and let's add a new project to our test folder. Right click, new project. I'm going to be using XUnit. You can use NUnit, MS-Test, whichever one you prefer. Click next. And I'm going to be choosing, actually, let me first grab this name and then back here. So right beside source, we're going to have our test folder. And let's select this folder, and I usually call them the name of the actual project and then test right next to it. Let's create that. Perfect, we have that created. Let's also create the folder structuring here. But I like to have our test as discoverable and as familiar as the actual project. So if I have entities, domain, I would also have entities and domain folder here, and that way you know that you're looking for the recipe repository test. You can find it under the repositories folder. Let's create this and then call this test. Public. And then we're going to make a test function. So we're going to be testing the insert. So let's say insert success, just as a name. And for XUnit, you have to decorate with fact in order for it to run. Let's resolve this namespace. And I'm going to be adding the service library as a dependency, just so we can gain access to everything. Perfect. Let's save this. So let's go ahead and write our test. So let's make the recipe repository first. So our recipe repository. Recipe repository. Resolve the namespace. And what we're going to try to test is the insert. So let's just start off by saying recipe repository dot insert async. And we're going to need a new recipe entity. So let's create that. Resolve that namespace as well. And let's see, let's give it the ID. Give it a random new one. Give it a title. Say fried chicken unit test. And description, same thing. And logo will be null. Created date is date time offset.utc now. We have that. And let's add a wait. And then get the rows affected. So rows affected. And we want to make sure that the rows affected is equal to 1. So let's say equals, and then we know we want 1 row to be affected. And at this point right now, our database should be empty and everything should be clean. So let's go to our database again. And I'm just going to do a select on this, and we have nothing right now. So back in our code here, I'm going to just put a debugger here, and I'm going to right click and say debug test, just so we can kind of walk through it a bit. And let's put the test explorer over here as well. Sorry, one sec, put it over here. And it seems like we have one compilation error. This one is regarding the service domain that's actually using the recipe. Because we deleted this method, it's no longer going to compile. So clean that up for now, and then we'll get back to it later. Back in our test, right click, debug test, make sure that this is running. As soon as it hits the breakpoint, let's start navigating. So let's just move this down a bit. I'm going to clean this up, and we want to make sure our test explorer is here. So let's go view, test explorer, and we'll just pin that over here as well. So let's step through this, and we should be stepping in a new recipe. So let's go through, make sure that the connection string is correct, and should be getting 1 back from this. Perfect. And that should be equal to 1. And now let's just do a visual check to make sure that the data is actually here. So that's good to go. Now that we know it actually inserted, let's just clean this up. And because we don't want our unit test to constantly be littering our database. So let's go here and let's actually add a transaction around this test to make sure that it doesn't do that. So what we can do is we can go var scope equals new transaction scope. Resolve that namespace, and we want to say it's transaction option as transaction scope async flow option enabled because we're using async await. Oh, and this needs to be in a using statement. So let's do that as well. And we'll copy all of this inside of here. Let me just scoot that over. So now you can see that the database action is wrapped in a transaction. And if we say transaction scope dot complete, it will commit whatever work has been done for this database action, which is the insert, into the actual database. But if we say have like a global variable up here that's like a Boolean that says commit to database equals false. And for the other test methods, we can have it read that value there. So we can say if commit to database is true, we want it to complete the transaction. Otherwise, we don't want to really see that. We just want to verify it's actually performing the action correctly, and then we can just roll back. So let's see if that works. So now debug the test. Stepped it through it. So now here we should be getting rows affected is still 1, but because we're within a transaction and this is going to be false, it's going to step over this. Rows affected is still 1. Transactions completed. Test is ran, and in our database now, we should no longer see the row here. Perfect. But if we do decide that we want to have that commit to the database, we can set that to be true. Same idea, run the test. Step through. And now rows affected should be once again 1. And we're going to say scope complete. And now when we let the debugger step through, go to the database, query it, we'll have our run row again. So we have the recipe object in, but now we need to think about the ingredients and instructions. So back in the code here, we can see that we have the ingredients list ingredients, and we will also have an instructions list. How do we go about including those now? Instruction entity. Let's first populate this with 1 row each to just have something to test. So we'll need to create new ingredient entity. Ingredient entity. And let's pass in the value. So this has the recipe ID. So that means that we have to move this ID a bit. So let's do that. So var recipe ID, like that, have that generated ahead. Place that there. Say the unit, ingredient, and the ordinal position. So let's resolve ordinal position first to be 0. Let's say the unit is in pounds. And let's have the quantity as 1 pound of, let's say the ingredient itself is just chicken because we're making fried chicken. And same idea here with the instructions. Let's add that. So new instruction. Scroll down a bit. And we should say recipe ID again equals recipe ID. Ordinal position equals 0. And the last one is the instruction. And we'll just say cook it. So we have this object now passing in to the recipe repository insert. Let's go back in the insert itself and start thinking about how we want to include those. So if we open the solution explorer here, go back up to repositories. I typically like to abstract away repositories by kind of the table setup or the entity setup. So in this case, I would create a ingredients repository and an instructions repository. Let's go ahead and add those. So I'm going to copy ingredients and add new class, repository, and same idea, instruction. Repository, and let's focus on the ingredients one first. Here, let's make it public again. Create an interface. And we're going to be focusing on the insert. So task, resolve namespace, insert, and rows affected, obviously, insert async. So the thing that's going to be different about the subsequent child objects here, the ingredients and instruction, is that we're going to be passing in some specific things already. So rather than creating a connection every time, you can reuse the connection from the recipe repository. So you can go SQL connection and expect a SQL connection to be passed into you. And because of that, we're going to want to be wrapping all of the work that we're doing within a transaction. In case any of the subsequent inserts fail, we can roll back the whole thing. So we'll kind of explain a little bit more. DB transaction and say transaction. And then finally, we're going to be passing in the actual entity. So it's going to be a list of ingredient entity. And that's going to be just the entities. So let's go ahead and implement that functionality over here. And I'll move this down just so you guys can see a little bit better. So let's clear this and say for each. And we know we want to say the entities, entity. So every one of these ingredients, we're going to actually do an insert. So we say connection dot execute async again. And we're going to write the query. So similar idea, you can get the script to generate it for you, but I have it ahead of time already. So I'm just going to copy and paste it over here. And we want to pass in the parameters. So we can say entity. Finally, what we want to do is we're going to pass in the transaction back into it so that we can ensure that everything is within the same transaction. So we're going to pass in the transaction. We want to be able to return the rows affected. So let's go rows affected 0. And we want to append that here. So this is going to be asynchronous. So rows affected plus equal to this, and we're going to await. And let's return the rows affected to the caller. So we have this for the ingredients repository. Let's go back to the recipe repository. And we'll have to do a little bit of refactoring here in order to get the ingredients when working. Firstly, we're going to be adding the ingredients through dependency injection. So ingredients repository here. And remember, we'll be registering all of these later to dependency injection container. Resolve this. And let's scroll down and see where we're going to be adding this to it. So right after the recipe has been added, we're going to want to add the ingredients. So insert async, and we're going to say pass along that connection. And now we can see we want to pass along the transaction as well, but we don't have one opened yet. So let's do that. Var transaction equals connection dot begin transaction asynchronous. We're going to await that, and this requires a using statement to ensure that it's disposed correctly. Let's move everything in and format it over. Perfect. And let's make sure that we actually open a SQL connection, because transaction cannot begin unless the connection is open. So we can say open async up here. So we make sure create a new connection, open the connection, begin a transaction. Now we have to pass in that transaction to our existing recipe insertion. And then we'll also pass that down to the ingredients insertion. And let's pass down dot ingredient down. Await that, and we'll get our rows affected. So let's update our existing rows affected here to include that. And we should have that working now. So our rows affected. So if we go back to our tester, we should be able to run this and get a result including the ingredients as well. Let's fix our errors first before we actually run it. So this recipe repository now will require the ingredient repository. So let's do that. New ingredient repository. And same thing, if we look in our error list, we should have one for this over here. So we can delete this now and finally resolve this through dependency injection later. Close this, back in our test. There's just one thing I forgot to do, which is inside of the insert async command. And that's right here. So after we actually calculate the rows affected for the ingredients, we should actually commit our transaction. So transaction commit, and this will actually save all the changes to the database. So we want to commit after we insert into the ingredients. So let's do that. Go back to our test and let's run our test now. So run it in debugger mode, wait for the breakpoint. So step through. We should see 2 rows affected. We'll let that complete just so we can verify in the database. And this value should now fail because there should be 2 rows affected. Perfect. And in our database itself, we should see 2 rows here, and we should see 1 row in our ingredients. And that's perfect. Let's go back and do the same thing now for the instructions. So go to instructions, I'm going to create the interface again. And since it's rinse and repeat, I'm going to go ahead and copy and paste that in here. Resolve the namespaces of everything. I'm going to implement this over here. And same idea, I'm going to just copying and pasting that in here. So this is very similar to ingredients, where we're going to have rows affected, iterate through the entities, and then ultimately return the rows affected. Nice and readable. And that's it. Perfect. So let's take this and go back to our recipe repository here. We will be injecting this as well now. Read that. To update my presentation configuration to include underscores. This doesn't happen again. But now we have the instructions. Let's go right after the ingredients. Rows affected plus equal await. Same idea, except for this time we'll be passing the entity dot instruction. Okay, that should be good. So back in our test, let's actually go ahead, leave commit to database as true. We're going to fix this over here because we've now added another overload to the constructor. So new instruction. Let's go ahead, run this. So we're expecting 1 instruction, 1 ingredient. Let's go to the database and kind of just clean everything up. So 1 deleted, that should be empty. Delete these 2 rows here. That is now empty. Back in our tester, rather than just letting it debug, I'm actually just going to let it run through. And I know I'm going to be expecting 3 rows because we're going to have a recipe, an ingredient, and an instruction row. Let's go ahead and run that. And that looks good. So we have a little green check mark here, which tells me that if I go to the database now, query here, I have 1 row here. Should have 1 row in my ingredients, and I should have 1 row in my instructions. That looks good. So going back here, let's make sure we turn this to be false, just so we don't keep littering our database constantly. Go back to our database, let's clean up the unit test. Now that the data has been cleaned up, we will continue next time with the get, update, and delete functionality. Make sure you guys like the video, subscribe to the channel, and I'll see you guys next time.